Well, we're going to finish up the section 4.3 lecture slides. So looking at our second example, a big question of this section's lecture, what aspect of sunlight might help protect against multiple sclerosis, or MS? So this is a study done in 2010 with mice. It was believed that sunlight offers some protection against MS, but the reason is unknown. So researchers randomly assigned a bunch of mice to one of three groups: a control group, where the mice, no variables, nothing was changed. Another group of mice were given vitamin D supplements to kind of mimic sunlight. And then another group were exposed to UV light. All of these mice, all three groups, were injected with proteins known to induce a mouse form of MS, and they observed then which mice got MS out of these three groups. So can the study be used to make conclusions about causality, about UV or vitamin D causing a lower rate of cancer? And that would be yes. The variables were randomly assigned, and there was a control group. So there's a random distribution, a random assignment for a treatment and then not treatment. All right, for each situation, we're going to go through and write down the null and alternative hypothesis, informal description of the strength of evidence against the null hypothesis. Are the results statistically significant? Formal decision about the null hypothesis using a significance level of 5%, and conclusion in the context of the question. All right, so in testing whether UV light provides protection against MS, so we'll look at UV light group versus the control group. The p-value is 0.002. And a separate test, we'll look at vitamin D versus the control group, and the p-value for those two is 0.47. All right, so let's take these one at a time, testing whether UV light provides protection. So we're doing UV light versus control group. The null hypothesis is that the proportion of the UV group minus the proportion of the control group, and these p's are the proportion of mice that eventually get MS, is 0. So we assume no difference in the two groups. All right, and the alternative hypothesis is that the proportion of the UV group is less than the proportion of the control group. That's what this alternative says. Again, we're looking at the proportion of the UV group that eventually gets MS. So if the p-value is 0.002, that means we have strong evidence against the null. Remember, if the p-value is low, the null must go. The results are statistically significant. These mean the same thing. If we have strong evidence against the null, that means we have statistically significant results, and we reject the null hypothesis. So we would conclude we have strong evidence that UV light provides protection against MS, at least in mice. All right, so we're going to look at the second test of whether vitamin D provides protection against MS. So here we have a null hypothesis. The proportion of the vitamin D group minus the proportion of control group that get MS is 0. So we assume no difference in the proportion that get MS in the two mice groups. And same as before, the proportion of the the experimental group, the vitamin D group, is going to be less than the proportion of the control group. And if you want to see that, just add P sub C to both sides of this inequality. All right, this is corresponding now with the p-value of 0.47. So that means we have little evidence against the null hypothesis. The results are not statistically significant. This is saying the results that they get on this experiment could happen just by pure chance about half the time, meaning the vitamin D might have had no effect. We do not reject the null hypothesis, and we cannot include anything about vitamin D in MS. Okay, we can't say that there's no difference, we just can't conclude anything. using this hypothesis test.